This should look really familiar because you should have done this in some pre-algebra class before you got to me. So I think it's pretty simple, or just it'll come back to you in like a second. You did a little bit of transformations in algebra class, right? Graphing with transformations. Tiny bit? Remember? No, we did. And you'll be doing more transformations next year. Let's review some of the words here. Transformation. It moves or changes a geometric image in some way, transforms it into something else. The pre-image, that's what we call the thing you're starting with. It's the original figure. We call it the pre-image. And the thing that you create is called the image after you transform it. Pre-images lead to image. See? Pre-image, image, okay? Look at the letters. We're going to use this prime notation. So A, that's the pre-image. When you perform a transformation on A, it becomes A prime. That's how you say that. B becomes B prime, and C becomes C prime. Let's say I did another transformation on this. What would happen? We have two primes, A double prime, B double prime, C double prime. So we can differentiate which A you mean. So if you just say A, that's your pre-image A. A prime is after one transformation, A double prime and so forth. Okay? That's what the little notation means. A translation. A translation. Well, you may have not used the big boy, big girl math words back then. They may have said it's a slide.
No.
Did you use that? Yeah. So, well, we're going to use the big boy, big girl math words, whether you did or not, before. So, and you can remember it's the slide. Look at that. Look how nice this is. Look at the SL, the slide in translation. So every point of a figure moves the same distance in the same direction. So you're sliding it around, but you're not turning it when you're sliding it. It kind of stays in that same orientation. A reflection is when you create a mirror image over a line of reflection. The baby words we learned were flip. And look, look, reflections, flip. How about that? You may remember this from when you learned how to graph a quadratic equation. Remember graphing quadratics? They had this thing called the axis of symmetry. Remember that? That's this thing. It's a line of reflection, and it just meant that your parabola was symmetric around it. We remember that. You forgot. Uh-oh. Now I got some reviewing to do. We'll remember. Oh, we'll take care of that. So it means that if this was a piece of paper and you fold it here, and that was your fold line, this would lay right on top of the other. They're reflections or mirror images. I had somebody say that your face is symmetric and it's a reflection. So if you put like this line straight down your face, you can say there's a reflection. Almost. I don't know if you've ever done that thing. Some classes do that where they take a picture and you take half of your face and you flip it around, and then it looks like some weird creature, but it doesn't look like you. Yeah, it's weird. We're not exactly symmetric. We try, but we're not 100%. A rotation is a turn. So right, you got T's, that's the turn, around a point. So you have this idea of a center of rotation, and everything kind of turns around that point. And then we have a dilation, which I don't have a little bit. Dilation, right? Just remember it. A dilation is a proportional, making something bigger or smaller. Pupils dilate, right? So different things. So that's a dilation. So we're going to look at all these things. Today we're just doing this one. We'll do the rest of them next class. So again, very short class today on this stuff. Very short lesson, rather. But we remember them, right? Kind of. Well, let's see if we do. So this one on your paper in the middle there, page 1. If you know, raise your hand. Don't shout it out. I'm starting with here. This is my pre-image over here. Which one of these is a translation of triangle A? Translation. Raise your hand if you know. If you know it, raise your hand. Raise it. That's it. That's the only people who know this. Translation, which is a slide. That's which one? B. Right? It's the same orientation, right? It looks the same, it's just a slide. So that one is B. Okay, raise your hand if you know what's a reflection, a mirror image of this thing. I'm sorry. Which one? D. D. And we're reflecting it over this y-axis, aren't we? So that is our line of reflection or line of symmetry. You can call it any of those things. And then I need the rotation of A, which is, which is the left? Yes, ma'am. so you have to kind of picture what's going on. I should be trying to. You can kind of figure there's some point around here in which this thing is turning. And eventually it's kind of straight upside down now, isn't it? Kind of do that big rotation. So we're going to rotate in degrees. So we'll talk about that more in rotation. Yes, sir?
So the most
Isn't it? Yep. Okay. So let's see here. Identify these transformations. If you know, raise your hand. If you know what that thing is. Jerry? What? Reflection. These big boy words. Very good, Jerry. And it's a reflection over this line. So we say it's a reflection over this horizontal line H. You know, we're always looking for what is it symmetric to? All righty, what do we have here? What's going on? What's going on? Wow, okay, 90 degrees. Around this point P. So a 90-degree one, what would be a 180 one? That would be all the way around halfway, right? So we went a quarter of the way, so that is a 90-degree rotation. Nice. Let's see what this is. What thing? Translation. Just sliding that over. And then this guy, dilation, right? This small thing became bigger, so that's the dilation. We stretched it out. Good. So you remember what they all are. No problems here. So we're just going to go a little bit deeper into translations today. So what you do is you move a pre-image. So all the points in a pre-image get moved the same horizontal and vertical units. So these are called, I don't know if I'm pronouncing this right. I think it's called isometry, but I could be wrong. Maybe it's isometry. I'm not sure how to pronounce it. But all that means is the pre-image and the image are congruent. So the size does not change at all on the image after you do that transformation. So we have rules. Tell you how many horizontal and vertical changes to make. So on the front there, that first graph, we're going to graph the pre-image. And this is the pre-image, A, B, C, D. So go ahead and graph them with me. Points A, B, C, D. Be sure you label your points when you graph. For example, here's -1, 2. Right here's the point, and that's A. So make sure you're like labeling the points as you graph them. So everybody's doing this, right? Everybody's graphing? Okay. I messed this up last time. Make sure we all get that graphed. Now it depends on, I don't know what you were told before you got here. When I taught pre-algebra, we did this exact thing. I don't know how much they go into it these days. It's been a long time since I taught. So this is the rule. It says take x and y. To the x you're going to add 3, and to the y you're going to subtract 1. Now you may have had a teacher who said all you have to do is start with this x, and then move to the right 3 and down 1. Don't they say go 1, 2, 3 and down 1, and that's another point? Right? What I want to be able to do though is for you to be able to actually write out what the coordinates are before graphing them. Let's put 0 here. So basically you start with A. Its x value is -1. You're going to add 3 to -1. I hope that's true. And then you're going to take the y value and subtract 1, so that you can actually see what the coordinates are before you graph it. So this one's going to be 1, 2, and 1, and there's A prime. B, again, add 3 to the x, -1 plus 3, that's also 2, and then subtract 1 from the y. So there's the 2, 4, so I can check that here, right? And then C, D, add 3 to 4, is that 7? 7 and a 1. So hopefully I got those right. Let me see. Let me graph them now. 1, 2. I find it's a good way to check each of these. didn't draw that one very well. So this should be an exact copy, but a slide 3 to the right and down 1. Now every point, even not just A, B, C, D, every point on here should be 3 to the right and 1 down. So you pick a random point, go 1, 2, 3, 1, 2, and it should be down at the match. And here's a picture, hopefully I did it right. It should look something like that. Scales are slightly different on the graphs. Right? Questions? No, you've seen this before, pretty much. Maybe not exactly this form, but we've done this. I want to kind of introduce a new concept called vectors. And this guy's from Despicable Me. Remember that guy? No?
Yeah.
You haven't seen Despicable Me?
A vector is an organism that travels of things.
Vector, I'm watching this like at the time my son was kind of little, and I'm like, all right, I'm gonna move this, right? And I was like, wow, there's a character in this thing called Vector. As a math teacher, I got very, very excited. Vector! I mean, he's a villain. I don't even care. He's in it. That's what I care about. So wait. We're gonna learn what a vector is from this dude. Wait. A vector. It's got direction, and you have to say it this way. And magnitude. Oh yeah. Right?
Oh, yeah.
Yes. It's from the movie. We have to say it that way. We just do. So what does that even mean? Well, you know what a direction is. A magnitude is a size. It's a number. Examples of vector. A velocity is a vector.
It's a line without the bottom. It's like when you write it.
Yes. Well, first of all, an example of a vector is velocity. Velocity has speed associated with it, that's its magnitude, and it also has direction. Where you're going.
Point of velocity.
My dad's a mathematician too, and I remember him teaching me how to drive. And the way I learned how to drive was velocity is a vector. Remember that? Okay, behind the wheel now. I'm like, what? So when you change direction, your speed changes too, because they are related. Your direction and your speed. Since you guys will be drivers too, I passed on that bit of information. Yes, my father was there. He still is. So we all are. So vectors are really important. You're going to see them in physics. There's a whole lot of vector math you're going to learn. This is just a little introduction into it. Okay. So what is it? So here it is. This is vector FG. So you have an initial point, and you have a terminal point, and the direction you say them is important. The FG says that's the direction of your vector. A little bit like array. The first number is how many you go either right or left, and the second number is how many you go up or down. So this vector, FG, and it does have this little kind of funny half arrow. I think a lot of mine look like arrows because I just couldn't figure out how to make it on the printout. You make these little funny looking brackets. They're not parentheses. They have these little guys here. That's how I know it's not an ordered pair, that it's a vector. It's kind of similar to an ordered pair. 5 right, 3 up. If you want to go left, it's negative. If you want to go down, it's negative. Yes, sir?
So a vector is a line that shows the direction.
There's a number associated with it.
A vector is a line that shows the direction and distance.
Yes. Yes. Okay. So this is the component form. FG goes 5 to the right, 3 up. All right. So this is on the bottom of your page. If I want to name this vector and put it in a component form, what's the name of the vector? Remember, you start with the initial point and you go to the terminal point. Yeah, Christian. Okay, so let's see. Name of the thing. And so basically, to find what the first one is, you say, how many over do I have to go? And he counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I went to the right, so that's a positive number. But then I went down 2. Down is the negative direction, and that's how I know where it ends. Now the arrow here, it's not like array where this goes forever. It's kind of stopping right here. It's done. That's your vector. Yes. And then let's look at this guy. So let's think about how you name that and what its component form would be. Does anyone try it? I don't know, but just try it. What? So how am I going to name it? Good. All right. So what am I, horizontal, right? Start with horizontal. right is positive, and then what's my second component here? Up or down? 0. So that's how you can name a vector and its component form. All right? Yes, ma'am. What? Well, if you do RS, that's naming a different vector because now your direction is going the other way. Remember, direction is important with the vector. So the reason I went this way is a little hard to see here, but here's where the arrow is. So if I want this particular one, I have to go in that direction. It's kind of like array. I have to go in that direction. Go the other way, you're naming a completely different vector. All right. So we can use this vector notation as another way to describe a translation. So let's do this one here. This is on page 2. Let's first graph your free image ABC. So let's graph that guy. So that's 0, 1, 2, 3, 3, 1, 2. There's my free image, more or less. So now I need to find my image points. And this, the way it works, this vector says 5 right, 1 down. It's the same thing as if you had a rule that looked like this. Just a whole lot easier to write. I don't have to write all this. It means the same thing. It means add 5 to the x, subtract 1 from the y. So I can create all my points here by adding 5 to 0, and then 3 minus 1. This one add 5. Now negative 1. Add 5. Subtract 1. Okay, and now I can graph these guys. So let's see, 1. These are primes. I think I did it right. The way I can check that is pick a point. Go right 5 and down 1. 1, 2, 3, 4, 5, 1. I'm getting to its prime component. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. So you can do it with the counting, that's fine, but I really do want you to be able to do it by figuring out what the new coordinates are as well. Right? Easy? I think I will picture to make sure I did it right. Now they're actually showing the vector, you're showing the little directions. That goes with it. This looks kind of cool. Now it's popping out of this. So I get very confused. What do we think? Easy?
Yeah.
Pretty much. All right, so we're up to the U-tries. So there are 2 sets of U-tries here. To graph the image. When you graph these 2 things I want you to do, I want to see the coordinates of your images. So make sure the coordinates are here as well. And it's the same free image for both of them. So you're going to graph that triangle EQR twice. And then this one is in rule form, this one's in vector form, either way. And then the second set, what you're doing is they're giving you a free image and an image, and you have to come up with the rule. So you can come up, I want it both in rule form and as a vector. So both ways. So give these guys a try. I'm kind of looking at this one. I hope I did it right. So I graphed the blue is the free image. And the red is the image. Notice the primes. Things that you should be having in yours. I want us to make sure you have prime notation there and make sure you've listed out the coordinates that you're using. How do we do, or are we still working on this one? Because we can check this one after. Are we still working on this one? Or do we figure out what they are? How do you do it? How do you even do it? A. So when I look for A prime, so I go like how many over, right?
Yeah, how many
1,
over?
2, 3, 4, 5. So, yeah. And then I went up, and up is positive. So you either wrote it like that, or you can say this, right? You really do it where it's like, well, I know what this coordinate is. This one is 1, 3, right? And then this one was, whatever it is, 1, 2, 3, negative 4, 1, 2, 1, must have been, -5, and then I had to do 3 plus some number to get to, 6. So you can kind of think of it that way as well, more mathematical way. So we should have gotten, part 3, it's up on 3. Right, this is what we should have gotten for both of them. Yeah, questions?